Today we'll be dealing with a thing called ambiguous case, and you notice that we've been working with triangles for the last few days, and we are actually talking about the ambiguous case when it deals to triangles. Now, the word ambiguous, you've heard of this before, but today we're going to clearly define it. Ambiguous means unclear or uncertain. So remember, I told you in some cases when you draw a triangle, there might be two possibilities for that triangle. Basically, it can lead to two different triangles which can fit the single information that you've just calculated. So when we say that a triangle is unclear, it means that there is a possibility of another configuration for the triangle. In some cases, the triangle is acute, and in some cases, the triangle is obtuse. The key idea is this: if you start with sine, write this down, then there's a possibility of two triangles. It comes directly from this chart. Now, if you remember, when we had an angle that was acute or obtuse, then the sine ratio was positive in both the acute side, which was less than 90, and an obtuse angle, which was also greater than 90. So remember that a triangle has 180 degrees. So if you got an angle that's acute, then you have most likely an acute triangle. And then if you have an angle that's obtuse, then your triangle ends up being obtuse with an angle that's greater than 90 degrees. And these are dealing with just simply triangles that are non-right. For these type of triangles, there's literally two solutions for these calculations. And now what we'll do normally is we'll just go through using sine law and finding our sine sausage. So let's begin. Now, I'm going to explain this to you. When you're given a triangle, by description, they'll give you a triangle with matching side and matching angle, but then you'll have another side that's given, but it's missing its appropriate angle. So there are two calculations that we're going to try and do. We're going to start by creating an acute triangle. So let's go and label that. So we come up with the acute solution. So let's draw a triangle that kind of looks like, almost like an equilateral triangle, to emphasize that. Now you label your triangle. For this triangle, you're going to label it ABC. And then you're going to have your little c, your little b, and your little a. Fill out your appropriate sides and angles. Now, here's the key. We're going to use our sine sausage on this. So let's find our matching sides and angles. So here's our first matching side and angle. And if you look, the only other side that we can work with is this, the B side. So let's do our calculations using sine sausage. Now we're missing the angle, so we're always going to start with sine B over 6 equals sine 30 over 4. Solving for sine B, we get, remember the trick we did in class? Link the two numbers that are not tied in with any letters, and then we get the following. 6 sine 30 over 4. So that gives us, when you do your simplification, you get sine B is equal to 0.75. So B is equal to sine inverse 0.75, and you get B is equal to 49 degrees. Alright, so I want you to imagine this is step one. Use the sine sausage. Fill out your triangle. Step two requires you to find the angle C. Now, the angle C is just this. Well, angle C is going to be 180 minus 49 minus 30 degrees, which gives us 101 degrees. Fill out your triangle. Step 3 is this. Use your sine sausage to find your last side, which is side C. We get this. C over sine 101 is 4 over sine 30. Do your simplification and you end up with C equaling 7.9. Your triangle. So you'll notice every time I do this, I always fill in my triangle. For stage 2 of this problem, we're going to imagine that we have a separate triangle based on our original angle that we calculated using the sine sausage. Now, remember, that's the problem. You remember that in our original problems when we were doing our acute and obtuse calculations, sine had two possibilities. So now what we're going to do is we're going to create an acute possibility, an obtuse possibility. So imagine that we actually took a look at this calculation for stage 1. So we say, therefore, there are two possible triangles. Now, this original angle that we found for B was acute. So instead of computing sine sausage for B, all we do is just take angle B and write it out. So for step 1 of this one, all you're going to do is just going to go angle B is equal to, well, 180 minus 49. So angle B equals 131 degrees. So now we'll redraw our obtuse triangle with this information that we have here and this information. I tend to draw my triangle that's been calculated from the obtuse angle for the very starting calculation to be very wide at the top and put that angle there. Now, for this final angle that we have here, angle C, all you're going to do is calculate, well, angle C is going to be just, well, 19 degrees. And how did we get that? Angle C was equal to 180 minus 131 minus 30, which gives us 19 degrees. So now all that's left to do is to find the unknown side, which is C. So for the obtuse side, all you're finding is angle C, angle B, angle C, and then side C. And you will use sine law. And you get this for C when you solve for C. And then you make sure you fill in your triangle. Last stage of this problem is to literally say what the triangles are. So I go back to my first triangle And I state all my sides and I state all my angles. And we have this for our acute description for our triangle. And for our second obtuse triangle, we have this. And you would get marks for this. Once you've done all your calculations, this, your triangles, and all your calculations. So here's question B. So when we do this problem, we're going to create an acute situation and then an obtuse situation. So let's go and draw our acute triangle. And now based on this triangle, we're going to create our sine sausages. So we have angle B and angle A and side B. So let's solve for angle B. So remember, anytime we have to find our first angle using sine law, we're gonna have to eventually check to see if the obtuse will work as well. But right now, let's find the acute. And we get this, B is equal to 29 degrees. So now let's find angle C. And we get this for C. And as we go, we fill in our triangle. So C is 111 degrees and angle B is 29. So all we're left with to find is side C. And we end with C equaling 29 centimeters. Now, the problem with this solution is when we come to the obtuse side. So now let's go and do our obtuse calculation. So with the obtuse calculation, the first thing that you do is you look at the first angle that you started calculating, and that just happens to be 29 degrees for B. So let's calculate the obtuse angle for B. So now angle B is 151. So let's draw that obtuse triangle. So you'll notice angle A is still 40, angle B is still 151, but the two sides are the same as before based on our original triangle. Now, the problem comes when you get to angle C. So let's take a look at what angle C is. So this was 1, calculating our obtuse. Number 2. So this is angle C. Angle C is just 180 minus 151 minus 40. Basically, you get negative 11 degrees. What you need to realize is this is impossible. Based on our original obtuse angle, we can't have a negative 11 degrees, so therefore there's only one triangle. So, only one triangle, and we have side A, side B, and side C equaling 20, 15 centimeters, and side C being 29 centimeters, and then angle A, angle B, and angle C is equal to 40, 29 degrees, and 111 degrees. And now, these are your questions that you have to work on. Good luck. You can hand in one of these questions below for some marks before your test, if you'd like.